Assalamu alaikum everyone. Today I'm here to give my presentation on code vulnerability and compromised software quality. It is a major cybersecurity threat and my course title is Information System Security and my instructor name is MD Maruf Hassan sir and the presentation is presented by me Kaushik Choudhury ID 211-35701. My next slide is about contents. What we will learn from this presentation, first of all, code quality, code analysis, and then static analysis, a way of prevention, static analysis, flow, taint, then security issues through code analysis, example of static code analysis, and then um, the limitation and future scope of static analysis. First of all, let's see the code quality. Basically, code quality is important for various kinds of reason. We will get benefit by improving the code quality. It will reduce the development cost and then improve software reliability, increase maintainability, enhance collaboration, and improve the user experience. And also, it increase the security level of a code. And then the vulnerability about the code. First of all, vulnerable code is what? Basically, it is a code that contains weakness that can be exploited by the attacker and to gain unauthorized access to a system or data or to a course or other harms. This weakness can be in the design or implementation and then or configuration of the code. Basically, how to measure the code quality and detect the vulnerabilities. We have three kinds of analysis. Those are static analysis, dynamic code analysis, and then code architecture analysis. My next slide is about code analysis. First of all, we will learn why code analysis is needed. Code analysis is needed for several kind of reason. Improve the code quality. Code analysis help to identify and fix the potential coding error, such as syntax error and then logical error. And then number two is enhance security. The code analysis increase the security level. There are might be some attacks, injection attacks like SQL injection attack, and then cross-site scripting and buffer overflow that can be prevented by the code analyzing by a code analyzing. And then uh, advance to code standard, we have to code analysis can check for compliance with the coding standard and guidance, assuring the consistency, readability across code bases. And then early detection of issues. Maybe there are some issues that the code is not running, that would be solved by analyzing the code first. And then we learn about how does code analysis do. Basically, code analysis do kind of two types of static analysis, like static code analysis and then dynamic code analysis. On static code analysis, we will see the structural error fixing, then syntax and then symmetric of code. And then dynamic codes analysis, here we'll execute the program, examine its behavior, identify the potential issues. And the code analysis tool can be provide varieties of information including code matrix and then potential code error and then security vulnerabilities and then coding standard violation. My next slide is about static code analysis, a way of prevention. First of all, we have to know the what is the Static code analysis. Basically, static code analysis is a software development technique that involves analyzing computer source code without actually executing it. This is types of analyzing can be used or for identify the potential bugs and then vulnerabilities. Here number two, you will see the code error categories. First of all, the locker, then critical, then major, then minor, and the information. And our next slide is also about static code analysis. Here we will see the benefits of using static code analyzing. First of all, improve code quality. Static code analysis can help us to fix the bugs of the code before they causes problems in production. It may can lead more reliable and maintainable to the software, and then reduce the security risks. Software, sorry, static code analysis can help to identify potential security vulnerabilities in the code before they exploiting by the attacker. They can help to protect sensitive data and prevent the cyber attacks. And then my third benefits of this increased development productivity. Static code analysis can help developer write better code, identifying the fixing potential problem early on. This can free up developer to focus more creative or productive task. My next slide is about the different tools. Here we will learn about the different tools for different tools where which we can use to static code analysis. First of all, sonar cube, then smiley, then we can see kodaki, then deep source, coverty, sonar cloud, and then click marks. And also here are some different tools like find bugs, getafix, hp 45, then 45, then infer, etc. My next slide is about the diagram of static analysis flow 10. Here we can see the diagram of this. Here we see from the source node, there it is going to string substring and the string buffer dot append. And this is the diagram of static analysis flow of 10. And my next slide is about security issue through code analysis. Maybe there are various kinds of security issues through code analysis. Some of them are injection flows. Basically, there are many kinds of injection pushing on that. There are SQL injection, then command injection, and then broken authorization. Broken authorization is an umbrella term given to vulnerabilities wherein the unauthorized and the attacker may broke the authentication and get into the code. And then code side splitting, splitting xss is a client side injection attack that occurs when a web application fails to properly validate the sanitized user supplier input. Attackers can inject malicious JavaScript code into web pages. Here also we can see the relevant pictures of this security issue. Here we have picture of SQL injection, then the broken authorization injection picture, and then the cross-site scripting XS, XSS picture. And my next slide is about security issue through code analysis. There are various kinds of security issue may occur, like insecure direct object reference and security misconfiguration, missing function level access control, buffer overflow, then improper error handling, insecure data handling, insecure storage, and denial of service. Then buffer overflow. Buffer overflow may occur typically when the program is not properly designed to handle input data of varying the length. Here we can see the uh, relevant picture of buffer overflow attack. And my next slide is about again buffer overflow, the consequences of buffer overflow. Buffer overflow is may causes program crashes. If the buffer overflow happen, the program I'm using or the code may be crashed, and then data corruption. If buffer overflow happen, the my data will be corrupted and crushing the incorrect calculation or file corrupted, and then availability code execution. In several cases, attackers may exploit buffer overflow to executing activity code potential, taking control in the system. And then the prevention of buffer overflow. There are several techniques to prevent the buffer overflow. First of all, input validation, then copying, then bounded copying, sorry, then the recommended address space layout, stack girl pages, then the safe coding practice, also regular vulnerability scanning. My next slide is about post bill analysis issue. There are two types, maybe error to analyze on post analysis, syntax error, and then logical errors. Here is an example of syntax error. We can see the code of syntax error and the potential sequences. The code will not exploit or run due to the indicated error. The program may behave unexpectedly or crash if the error goes unnoticed and the code is uh, deployed. My next slide is about pre-build analysis issues. Pre-build analysis issue is a also crucial step in software development lifecycle. So there are common pre-build analysis issue like syntax error, logical error, then date code, security vulnerabilities, code smells, duplicate codes, long method, and then complex classes, unnecessary complexity, poor code documentation. My next slide is about benefits of pre-build analysis. There are various kinds of benefit like early error detection, then improve the code quality, enhance the security, then reduce development time, then easier to maintenance, and then the tools and techniques for pre-built analysis, static code analysis tools, then code review, style guides and listeners, unit testing, then continuous integration. My next slide is about the limitation and future scope. First of all, limitation. Static analysis tools often produce a large number of false alarms. Manually triggered static analysis tool can be time consumed process. Programming language dependency. Static analysis tools are typically designed for specific programming language. Static analysis tool typically do not process any fixes for the problem they identify, and the static analysis tools are not intelligent. and cannot understand the context of the code they are analyzing. The future scopes, machine learning can be used to improve the accuracy static analysis tool. Artificial intelligence can be used automated process static analysis. Neural language processing can be used to improve the usability of the static analyzing tool, and then improve the accuracy of static analyzing by reducing the false alarm, and then auto fix with the high accuracy is the future of software quality through static analysis. And my next slide is about the references where I have taken this data. And thank you everyone, this was my presentation.